Hello, ladies and gentlemen, and distinguished guests. I'm Jeff Hamilton, and I want to talk to you today about mining in the year 2050 and some of the implications of a number of technology trends in that regard. There's three primary things I want to talk to you about today. The first is, what's a possible future look like? I was quite honored asked to get to speak about this subject in the year 2050 and did a fair bit of research to look at uh, a set of things that I thought would be important in the context of the year 2050 and how that would affect the extractive industries with mining in particular. So one thing I want to talk about today is a possible future. What does that look like in 2050? Second of all, I'll talk kind of broadly about digitalization, the Internet of Things, Industry 4.0, digital twins. How does all that stuff work together? And then lastly, kind of bring it back to what is Dassault Systèmes doing and GEOVIA in particular in this regard. So when I started considering the year 2050, I essentially jotted down a list of things that I think will have a significant effect in the future. So we have roughly 33 years until we get to 2050. And it occurred to me that I should probably take a look backwards and look at time tranches of roughly 33 years to see how much change we've seen technologically, societally, and otherwise in that period of time. And then I tried to correlate that backwards, and forward integration with technology change. And so, when I look at the rate of technological change, as we've gotten into more recent times, we see significantly more integration and more technology applied, really as a strategy overall for human survival, and I think particularly around the year 2000 that trend increased significantly for the amount of change. So I came up with a set of things to think about in a potential future, a possible future. It's not a comprehensive list by any means. There are many other things I could think about, but these are all things that were interesting to me. And I thought this would have a significant effect on what mining looks like in the year 2050. So starting with population, the UN estimates that there will be between 9.6 and 10.1 billion people in the year 2050. In December of 2017, the Earth's population was estimated at about 7.6 billion people. So this population increase represents between a 21 to 25% increase to our current population. We also see that the regional changes in population will be uneven. According to the World Bank, more than half of the global population increase, actually about 53%, by their estimates, will occur in Africa, which will add 1.3 billion people to the current population. And what's kind of shocking is that's a 109% increase over the 2015 population. Further, it's been estimated that by the year 2100, 80% of the world's population will live in Africa or Asia. So when we think in terms of urbanization, the population increase that we'll see is largely going to be urban. We see increased work specialization. People want to live in urban centers. In general, they view that as a better way of life. We've moved away from agriculture, and again, that's because of work specialization. So by 2050, some 70% of the Earth's population will be in these urban centers. So that means that there's about 2 billion people that will have to be added to the existing urban centers and the new ones that have yet to be built. When you consider the majority of this population increase will take place in Africa, we're faced with a specter of mega cities having to be developed. So today, we've got Lagos in Nigeria, which currently has a population of about 20 million people. And Lagos, in essence, will, in the next 33 years, will have to expand to 40 million people. So the stress on resources that takes, the amount of infrastructure that has to be built, the amount of infrastructure that has to be refurbished, the trillions of dollars it's going to take to build all this stuff just really makes this a non-trivial problem. And so it's interesting. There's a guy, a professor from Oxford, Tony Venables, who said a few years ago that in reference to the size of the scale of Africa's population increase, that for Africa alone, that means that we have to build 2 Londons every year for the next 30 years to cover this. And what what's interesting, I think, from a mining standpoint, is that when you have that level of urbanization, the renewal that's likely to take place with respect to natural resource use or recycling, if you will, in a manner of speaking, um, will be very different, right? So how things are consumed and reused will be definitely affected by that urbanization and that population um, density. So another thing I think is pretty interesting is societal structure. So as humans, for the last 10,000 years, we've lived within the agricultural revolution. And previous to that, we were really bands of hunter gatherers, which weren't sedentary, moved around, used a wide area for the resource base. With the agricultural revolution, we had, intense agriculture, cropping systems as well as animal husbandry, which allowed us to sit in one place. And the city states were built, and then ultimately nation states came out of that because of that more sedentary lifestyle. What's interesting today is that there's some dramatic changes in technology that may have an effect on this. Two things in particular are distributed autonomous peer-to-peer trust, and then secondarily the sharing economy. So distributed autonomous peer-to-peer trust, some that's DAPT, DAPPT. Some people call it ADAPT, which is autonomous distributed peer-to-peer trust. This is really about blockchain and the ability to provide a chain of custody through cryptographic methods for a variety of things. It's not necessarily about cryptocurrencies. Cryptocurrencies, whether you view them as a value store or a currency, is a bit of a different thing. This is really about the ability for peers to exchange value that have no knowledge of one another and who have never met, and they don't require a central authority to arbitrate or validate the validity of somebody's rights, whether it's selling property, whether it's exchanging a good, whether it's collecting value from somebody and demonstrating that it's been paid. This distributed autonomous peer-to-peer trust has a significant implication with how we organize ourselves because the needs of the nation state or the requirements of the nation state potentially change. Additionally, when you look in terms of the sharing economy, which a great example of that would be Uber, that's a classic example, or Airbnb, where you have asset-less or asset-light organizations that really don't require people to own as much stuff. They can pay as they go. So if you look at Dubai, for example, Dubai has a very different model for how they go about doing things because they have no taxes in essence, and you pay as you go. So, if you need to use something, the cost of that is built into it as you use it. And, when we think in terms of the population demographics is another aspect to this, millennials have a very different view towards owning assets and how they want to live. So when you think in terms of this increase in population, increase in urbanization, and the ability to have distributed autonomous peer-to-peer trust, and then the sharing economy, that has some pretty significant implications for society going forward. I'm not saying that we're going to have this significant change overnight. We've got 33 years to see it, but Bill Gates once said that people grossly underestimate the amount of change that can take place in 10 years and underestimate the amount of change it's the amount of change in 10 years they underestimate, and they grossly overestimate the amount of change in 3 years. So in the context of 33 years, it'll be interesting to see how things change. It's quite possible that we see some significant societal changes. So natural resource consumption is another. As population increases, even with static per capita consumption, natural resources consumption will be significantly impacted. How that works exactly, I'm not really sure. But with a 20 to 25% increase in the population, obviously there'll have to be more resource extraction. Now, if you look at per capita consumption, based on the individual per year, it's likely to go down because of urbanization, and ultimately this leads to cradle to cradle product lifecycle management will have to be developed to ensure that we're utilizing those raw materials in some sort of optimized fashion. To that end, it was kind of interesting that Apple announced in 2017 that they would stop using freshly mined minerals for their products, and obviously that has a significant implication for the mining industry. And when we think about there's fixed amounts of mineral and bulk commodities that are not easily scaled for significant population increase. Um, we're going to have to change the way the consumption patterns work. From a natural resource extraction techniques, there's new in situ techniques that are being investigated. So the ability, for example, to let's say that we have a much greater capability to understand a resource, right, through adding geoscience and geologic understanding and interpretation, boreholes, seismic stuff, investigation. If we can do that and we can more accurately characterize where the resource is and reduce the uncertainties, then potentially we could drill in certain places and use in situ extraction to significantly reduce the impact of mining. So human cognition and human enhancement is something that's quite interesting as well. When you look at it today, there's numerous companies that are working on, for example, Elon Musk's company, Neuralink, is developing ultra high bandwidth brain machine interfaces to connect humans and computers. Additionally, there's other things from exoskeletal things that allow us to perform beyond our, muscular and skeletal capabilities today. To there's a company Mox that's producing essentially replacement prosthetic eyes that have Wi-Fi embedded, so you could actually be able to communicate what you're looking at, which I think is kind of interesting from a social media aspect. I don't know that I want that many updates from people on everything they see, but there's other stuff too, right? There's night vision that could be added to eyes and our ability to see these things. And for example, maybe somebody has the ability to have increased vision that allows them to more accurately look at things in the face, in terms of mining, and that's then immediately sent back somewhere else where people do it and maybe run an AI on image recognition. These are all things that could significantly change the way we deal with things. One of the things that's I think interesting about this, brain machine interface thing is that, and Elon Musk talks about this with Neuralink, is the ability essentially to communicate, back and forth between people, like historically we would consider more like telepathic type stuff. All quite interesting. I think whether it's MOTES, MOTES, as in remotes, which is a form of Internet of Things tags, whether it's remotes that are installed into the human brains or not, or it's something that's external to the skull that's reading synapses or actually firing synapses. It remains to be seen what will happen. I think biologically, the ability to do all this will, it's a long path to be able to implant things in the brain in some way that makes a big difference. But with 32 years, who knows? There could be quite a bit of change with taking place in that time frame. Robotics. So with robotics, we have Boston Dynamics, for example, has the Atlas robot, which stands about 1.5 meters tall, can carry a 75 kg payload, has LiDAR and stereoscopic vision. And the robots that follow in Atlas's, follow Atlas, very likely could be used in underground mining and other areas where today are quite harmful for humans. Places such as the face, and we will see robotics dramatically used into the future. If we look today from a manufacturing standpoint, we've got robots that work cooperatively in 6 degrees of freedom and in aerospace, for example. And there's a lot of other things we can do with robotics where they're kind of ambulatory in the context of something like the Boston robotics stuff. So from an energy standpoint, we know mining is very energy consumptive, and the activities would benefit from more renewables. This will reduce carbon footprint, but one of the problems is that renewables frequently aren't near the load, and also the power generations is intermittent. So when we think in terms of utility scale batteries, this is a significant opportunity in mining because we would have the ability to use renewables and then store them in utility scale batteries. And then at peak load times, the batteries can be used to power the mill and the mining operations, which has the net effect of reducing the average cost per kilowatt hour. Plus, it also reduces the carbon footprint. There's ways too that the distributed autonomous peer-to-peer trust or the blockchain stuff could be used to demonstrate that as well. A couple other things, I'm jumping around a little bit, but extraterrestrial mining. So looking particularly at the Earth's moon, there's a number of companies that are looking at, well, they're focused on private spaceflight and exploration, but they're also looking at doing things on the moon in particular. So Moon Express, as an example, is working to send spacecraft to mine the ice and the poles of the moon. And the reason that's important is that that is the basis for rocket fuel. So, hydrogen and oxygen. And that could be used as a refueling base. So, if you have a space vehicle that escapes Earth's atmosphere, it takes a lot of energy to do that. You could refuel at a base on the moon, and then you could, go on to Mars or other places such as that. Also, we've seen that because of the number of crashes that the moon has, because it doesn't have an atmosphere, asteroids don't tend not to burn up in their atmosphere because it doesn't exist, so they actually hit. And there's a lot of platinum group elements, it's postulated, that are on the moon. Additionally, there's asteroids in the vicinity as well, or the vicinity of the Earth, that could be mined for what we call rare earth elements. I guess they'd be more like rare moon or rare asteroid elements. They could be used for future lunar habitation models or space stations and a number of other things. Also, just recently we saw the Falcon Heavy from SpaceX launch, which was really a pretty exciting thing to see. So artificial intelligence is another area that's quite interesting. We're seeing that today, AI is starting to be used in mining. A lot of things around image recognition. And processing things there's really three levels. There's process automation, there's cognitive insight, and then there's cognitive engagement. That's from an article in Harvard Business Review from Davenport and Ronanke. But what we see is that in this context of the year 2050, the futurist Ray Kurzweil had predicted that we would have what's called the singularity by 2045. And the singularity is when humanity transcends biology and the intelligence of machines will be infinitely greater than that of all humankind combined. Now, when you think about a general artificial intelligence, which is what Kurzweil is referring to with the singularity, and you think about the robotics, it's quite interesting. It's a potential future that's a little bit mind warping from my context, but these things are changing and we're moving that direction. I think these problems are significantly hard, but we're moving that way. And again, if I go back to Bill Gates, we usually grossly underestimate the amount of technical change that's possible in 10 years. So from a labor standpoint, when we think in terms of mining, there's a lot of new skills that are going to be seen here. We're pulling people out of the dangerous elements of mining, say a lot of the underground mining, and we're using automation with that. You really change the context in which people work. So, if you're using an autonomous miner underground, then maybe somebody's in a control booth in a major city, so they don't have to actually get transported to and from the mine and be away from their families. Maybe they have to have more skills with, you know, um, let's call it computer understanding. They don't have to be programmers, although data scientists and programmers become much more important in this context. But the nature of their job changes. They're not at the face on the machine servicing the machine. They're looking at probably some number of machines remotely in working in a context similar to that. So some of the things that they probably need to understand will be important in that context are, you know, um, PLC or primary logic controller training, computer engineering, human machine interfaces, electromechanical maintenance and repair, electro-hydraulic maintenance and repair, instrumentation, process control, and then of course, as I said, there's going to be lots of data scientists and mathematicians that need to do this. And we're going to have to provide all these people with kind of internet access and mobile. So the ability to communicate all these things and have all these work skills will change. So a couple other items here I think that are noteworthy is one is Gartner has estimated that in the year 2050 we'll have 30 to 35 to 50 billion Internet of Things devices, or as we kind of call it at Dassault Systems, we call it the Internet of Experiences. So we're in the experience economy. And this is another kind of mind-boggling thing. Everything will be it'll be tagged, or you can call it a mode. And the tag essentially is a device that inherently can communicate, frequently knows its geospatial location, and frequently has a sensor that tells it something and then ultimately you something about the environment with which it's working in. So whether this is temperature, RPM, acceleration, vibration, pressure, vectors of movement, whatever, you have all these devices that aggregated together provide all kinds of information. And what we end up having to do is we have to be able to capture this data, store it, model it, retrieve appropriate actionable intelligence, and do some data science things on these things as well. And this all goes back to the platform considerations, which is the last element I'll talk about here. So with the platform considerations, everything is connected. When we think in terms of human enhancement with brain-machine interfaces, that's pretty intriguing, right? All of the things go to the platform. We interact with a platform on a daily basis. I mean, all of us, we use the platform every day, or a platform. Whether it's your email account is probably platform-based. If you do banking, it's going to be platform-based. If you fly in airplanes, the app that's on the phone that communicates information to you about your flights or your reservations, that is all platform based. And imagine now the context of a world of 30 to 50 billion IoT devices, all of which are connected to the platform, all with data science tools that help you get actionable intelligence. Artificial intelligence agents, sometimes we call them cobots or cooperative robots, that are pieces of code that do things with us. This is really tremendous in the context of mining and what that looks like in the future. So next up, let's talk a bit more about the Internet of Things and the fourth industrial revolution. Really, what the Internet of Things is really about is unlocking the data and knowledge that's tied up in disconnected systems. So frequently there's disparate proprietary systems. I mentioned tags earlier and motes or remotes, which are fundamentally, it's a device that it's connected. Frequently, it has a geospatial location, and oftentimes it has some sensor that tells you something about its environment. So once we aggregate those things together and kind of bring the data together that's in proprietary disparate systems, we ubiquitously connect what we call the Internet of Experiences. If you notice, it's gone beyond things to experiences because, from a Dassault Systèmes standpoint, we look at the fact that we exist in an experience economy today. So I'll give you some examples. So if you go to buy an Apple Watch, for example, whether you go to the Apple Store or you go to the Apple website, or you do it from an app on your phone, you're really getting an overall experience. It's not really about the product. It's about all the elements of the way you shop, of the value that's delivered, the value that continues to be delivered, its participation in an ecosystem. Another example might be, food. So we all have to nourish ourselves, but there's a significant difference in the experience between going to a fast food place and a place that has Michelin stars. So it's a very different kind of experience with respect to dining. And as consumers and frequently business customers, we're very interested in the overall experience and the value that we get out of a particular type of experience. When we think in terms of Industry 4.0, we see that there's really four industrial revolutions. The first was around, mechanization and some sort of power other than human power or beasts of burden. So that's water power, steam power, and that was really the first thing. You could think about, grist mills, flour mills, things like that. Again, in the context of the agricultural revolution in the last 10,000 years. The next major revolution in industry was really around mass production. The assembly line introduction of electricity. So I think in terms of Henry Ford and his comment that You can have any color you want on the Model T as long as it's black. So standardization of process became very important. Then the third big revolution was really around adding computers and automation. This was the initial forays into robotics. This was looking at, process flow and manufacturing engineering kind of a significant way. The fourth revolution is where we really look at cyber physical systems, where all of the elements in the manufacturing process within the industry, it's not just manufacturing, but within the industry, communicate with one another. And this is really where we see the Internet of Things plays a central role. And when we think in the context of the next 33 years, I think we are definitely in this fourth industrial revolution right now. And we will see this industrial renaissance because we do have the aggregation of all of these Internet of Things tags or motes, and our ability to process vast amounts of data and get actionable intelligence out of it will really allow us to inform what we're doing. This is where the concept of, a digital twin comes in, where you're really you digitalize reality, and then, so you model it, and then you simulate and optimize this um, digitally before you do things in the real world so that you can most efficiently work on your processes. So the four industrial revolutions, it's important to understand that, and that we're absolutely in the fourth industrial revolution now with the cyber physical systems. So let's switch now to the Internet of Things and mining, or sometimes we call it the mining Internet of Things, and kind of bring a bunch of this stuff together. So for Dassault Systèmes and GEOVIA, what we look at when we think in terms of the mining Internet of Things is all of these sensors out there. Again, it communicates frequently. It has a geospatial component to it, and it has some sensor that tells us something about the world. So all of those things, sensors, communicate into a central repository. There may be schedules, there may be physical effects from drill and blast, there may be fleet management systems from haul trucks, there may be information about the mill or processing, about mining, about what the production is. All of this stuff comes in, and it's processed, and then we use a business platform. Frequently, there'll be a set of KPIs that are associated with whatever you're working with, so that the people that are involved can, understand how the performance is going, and chart it, and then really understand how that the work is affected. And if you notice here, you've got the individual with the hard hat shows the loop back out to the Internet of Things, because this is a closed loop system, or ideally it should be. So for us, we see that the mining Internet of Things is digitally connected, it's data driven, it's model based, and it's virtual plus reality. And this really becomes the basis of the digital twin in mining. So there's a lot going on this slide, and this is really around the Internet of Things and the digital connectivity in mining. And I won't go into all this, but I'll just provide some examples. One of the things we could do is we can use AI or machine learning to apply to exploration drilling and have a better understanding of how to drill and where to drill and what the results are, and get them back quicker. We can look at measuring while operating. So maybe it's from drill and blast, we get information from sensors that add data to our geologic model, by say downhole sensors that provide data in real time, as well as having to send stuff off to the lab, and then we can rapidly do implicit geologic modeling. We also can reduce the uncertainties and then update, the block model and then the schedule with that. But there's many elements to the Internet of Things and the digital connectivity in mining, especially when we think in the context of 33 years from now and all the factors that were discussed earlier. So bringing this all together from a Dassault Systèmes standpoint, we term all of these things, and our approach to the market and the industry is the 3D experience mine. And that's, again, bringing the Internet of Things and the digitization of mining together. So for us, what we really look at initially is we would like to connect things in a way that provides digital transformation, but it's a stepwise approach. So initially, we want to create stability in the system. So once we have the ability to see into what's going on in the operations, because we've got things wired up through the Internet of Things, we're able to aggregate the data. We know what our business KPIs are around that. We create stability in the process, and stability can be just amount of tons that are processed per shift or per day or per hour, um, to power consumption. There's a variety of different things, and really when we start to understand that, then we can move to excellence, where we understand the operation, we can see what's going on, we're reducing the uncertainty, and we create excellence in our operation. And then kind of the top piece here in this hierarchy is the ability to be agile. So we could respond to external factors, changes in business strategy, market conditions, lots of stuff. So our our view is that the 3D experience mine is digitally connected. It runs autonomous software agents. It uses machine learning. Essentially, it becomes a decision support system, because we're providing actionable intelligence as opposed to just lots of data. And we look at this from a computing standpoint, that we would use either on cloud or on premise solutions, or some hybrid that's a combination of the two. And ultimately, we see the Internet of Things is a foundational component of all of this. So looking at this a bit more diagrammatically, what we see kind of from the bottom up here is that we've got our external data sources, whether they be environmental, plant data, equipment data, and other sensors that are wired in as part of the mining Internet of Things. And that goes to some sort of edge gateway. So the edge is a kind of a specific piece of nomenclature within the industry, but um, the edge can be firmware that's running in real time on devices, that's pushed out. It could collect data and do things episodically, but ultimately we have this interface that aggregates this Internet of Things, mining Internet of Things data, and then that moves that up to the business platform, which within Dassault Systems, this is our 3D experience platform, and we use dynamic semantic data models to capture, store, aggregate, analyze, visualize data, all in the context with appropriate cybersecurity and data warehousing. And then on top of that, there's a series of applications that really become the technology suite for the 3D experience mine, around modeling, design, simulation, analytics, business operations and processes, and any other applications that provide reporting and information to people, whether they're in the corporate office or whether they're on the ground or underground doing the actual mining work. And we view this as really, this is our framework for a digital mining platform. So to put this in the context of the ISA 95 tech stack, our view is that Dassault Systems is very big on partners. We have close to 13,000 partners, from a technology standpoint, academic standpoint, research standpoint, lots of stuff. And so we view that we participate in different places here. So you see the blue boxes, those are really where we plan on having and are actively developing solutions for the 3D experience mine. If you notice, there's other areas that are lower on the stack, which is not areas where we plan on participating in, but overall we want to provide visualizations to this. And the goal is to work together with others to create this value. So within this new age of experiences, we view that there's new business models and new ways of looking at how we deal with mining and the mining industry overall. And we'll talk about that a bit next. So within the 3D experience platform and our 3D experience mine, there's some next generation mining technologies that are important. This graphic that you see, the icon, which is the 3D experience compass, has 4 quadrants. The northern quadrant is the social and collaborative quadrant. And from a mining standpoint, that's where we view our 3D Experience Mine and the 3D Experience platform as being the single source of truth and allow enterprise collaboration. Many of the solutions that are in mining today are really around individual contributions to the process versus enterprise contributions. So we look at changing that with these technologies. In the eastern portion of the compass here, we have the II, which stands for information intelligence. And in the context of mining, we view that as around big data analytics, geospatial data management, and semantic modeling. In the south, we have V plus R, which stands for the virtual plus reality. And this is where we're doing things in mining, such as geomechanical simulation, to look at rock mechanics based on how the mining is being done and predicting what that geomechanical situation might be. Additionally, we're also looking at mine planning with scenario analysis. So, we may run thousands of different scenarios on the virtual side prior to getting to the real. This goes back to that digital twin concept. So in the West, we have 3D, and this is really around modeling. So I talked before about with the digital twin, the ability to model, simulate, and optimize operations digitally before doing it physically. So some of the things we're working on here is parametric design. So as an example, what we would do is we might change one parameter within our mine design. So maybe that's haul road width, and then automatically all of the other parameters that are associated are automatically updated by that single change. So that's there's thousands and thousands of engineering hours spent working on the mine design, and the ability to change things parametrically is very powerful. Likewise, we're doing things with image analytics. So this might be defining the ore or the resource at the face and doing it in an automated fashion through stuff that's on autonomous miners as an example. And additionally, we have geoscience modeling, where we're looking at bringing in multiple types of geoscience to do resource modeling and in an attempt to mitigate the uncertainties to the greatest extent possible. From an integrated mine planning standpoint, our view of the evolution is, the traditional method had a series of activities that were a bit disparate, and they didn't work in a parametric fashion. What's being asked for today, primarily from the mining industry, is parametric modeling, and that's what we're hearing most about, and people in the marketplace are dealing with that. So we're certainly dealing with that, but our ultimate goal is to really to get to stochastic modeling, where we have the ability to simulate end-to-end uncertainty with parametric modeling, so you can review an entire set of results instead of just one, and you can change your KPIs or whatever the business processes are overall. And ultimately, we would like to be able to get to generative design, where we say, here are the outcomes that we seek, cobots, if you will, go generate the design that meets that, and that's ultimately our vision. When we look at parametric modeling and the industrial Internet of Things, we contemplate how we can measure while we're drilling or we're operating, and then integrate that into mine planning. So we can take real-time drilling parameters and update the geologic model and the block model automatically, which then would automatically generate a new plan and schedule, which can then be sent back out and acted upon. There are likely to be some dramatic technological and societal changes by the year 2050. And the mining industry needs to innovate, starting with digitalization and IoT integration. At Mining Indaba 2018, this has been a significant portion of the discussion. So that's encouraging. Everybody's trying to figure out how to do this. One key takeaway I'd like you to get out of this is that digital twins allow operations to be modeled, simulated, and optimized in virtual space before having to spend the money to do it in the physical space. There's going to be lots of new job types that will require a new education and training. If you think about it, many of the people that will be working in the year 2050 haven't even been born yet. So we need to define what that future looks like. And ultimately, I think there's going to be a new normal, which is really where parametric connectivity in real-time data flows work in a context where everything is upstream and downstream aware. So it's all parametrically connected, if you will. And then everything will be platform centric, even if it's on the edge. So we know that mining has some unique challenges with connectivity based on where mining is done, but everything will be connected in one way or another. So with that, I would like to thank you. I would like to add a note. This presentation was originally done at Mining Indaba in Cape Town on February 7th of 2018. I've recorded this a little bit longer version than what was done originally because a number of people had been interested in the presentation and we didn't do a formal video. So hopefully you found this valuable, and we'll look forward to seeing what the future holds. Thank you.